Hello everybody, this is Dr. Christopher White, and in this presentation we are going to continue looking at streams and flooding. So in this video we're going to think about what features characterize braided river systems, and this is going to correspond to section 16.7 of your textbook. So in this diagram here we can see the standard environment in which we would expect to find a braided river system forming. So most braided river systems are associated with areas of elevated terrain, and that is because these areas of elevated terrain often have very high rates of precipitation, so that's plenty of water, and they are also areas where we have very high rates of erosion, which means there is abundant sediment being created, and this sediment will be transported by the braided river system. So here we have our area of elevated terrain actively being eroded, so we have lots of sediment being formed, and that sediment is going to be transported by the braided river. Now in this particular instance, the image we have isn't 100% representative of a braided river system. Normally, braided river systems are limited to areas of elevated terrain. So we'll find them in mountains or we'll find them in very hilly areas, so foothills. Typically, once you're past the foothill environment, the gradient will shallow, and so your braided river system will often transition into a meandering river. Now, in this particular instance, this isn't happening because this example was taken from New Zealand. And in this instance, you can see there isn't much distance between your foothills here and your ocean here. So your braided river system never has time to transition into a meandering river system. So don't think that most meandering river systems make it all the way to the coast. They often don't. 99% of them will turn into meandering river systems, and it's that meandering river system that will actually deposit the sediment along the coast. Most braided river systems are going to be limited to the area of elevated terrain right here. So within our braided river system, what do we have? Well, we have lots and lots of sediment, and this sediment is very often quite coarse because the water in our braided river system is quite energetic. Because remember, we are dealing with an environment that very often has quite a high gradient, and so this means the water is falling quite quickly, and that means the water is going to be very energetic, so it can move these larger clasts. Now, when we look at our braided river system close up, what do we see? Well, we can see that here's our braided river system, and you can see we have multiple channels all interacting with each other, all crossing over each other. And you can see that within the main channel itself, we have these bodies of sediment which are referred to as braid bars. And these are going to be made up of this coarse sediment, lots of cobbles, lots of gravel. Now, the thing is because the sediment in here because there's so much sediment in here, it means that these braid bars never really have time to consolidate themselves. They're relatively weak. And because you're dealing with a flow of water which is quite energetic, it means these braid bars will very, very quickly be broken down and degraded. And so what will happen is the channels, the streams of our braided river system will be constantly shifting position. And this is because, as I said, they're moving through sediment which is very loosely consolidated, so the river has the power to pretty much push into whatever area it wants. There's nothing stopping it when it tries to move, and so it can go where it wants to. In terms of the river itself, as we said, it's very energetic water, and so this means we can move these larger sediments, so we expect to find lots of gravel, lots of cobbles, lots of sand within our river sediment here. Lighter sediment, such as silt and clay, is carried by the water in suspension and gets transported out of the area. So the sediments associated with braided river systems are often very clay and silt poor because that sediment never has a chance to be deposited. The water's moving too quickly, and so it gets transported out of the area. So in terms of braided river systems, what we find is that they form in areas where we have steep gradients, abundant sediment supply, and also variable flow. So because the water is moving quite quickly, it can move a large range of class sizes, but the speed at which the water is moving will not always be consistent. Sometimes the water will be moving quickly, and sometimes the water will be moving more slowly. And as you know, in areas where the water begins to slow down, it's naturally going to be depositing some of this coarse sediment. Now, when we look at our braided river system as a whole, we know that we have multiple channels all running parallel to each other. But if we look at them all together, you will see that the river system itself forms a relatively straight channel, which does not have much sinuosity to it. So you can see in this picture very nicely, the channel itself is nearly completely straight. And this is a reflection of the fact that we have water which has lots of energy and very loosely consolidated sediment within the channel itself. And so this means that rather than our river having to move around obstacles, our channels can simply punch through this loosely consolidated sediment and go where they want. And so it doesn't really have to worry about meandering around to get around stuff. The river can just literally work its way along and take whatever path it finds easiest. Okay, thank you for watching everybody, and have a good day.